Hello, everyone. We are continuing on the read of the 11th Hour Preparedness, and it is a book that I have written. I'm the author, Tyler Woods, and we pick up on page 108 and begin or continue in the read of the part of the book that deals with food and water. And we will continue here with Caching Supplies is the title of this section. With a history and precedents for confiscation of private food resources, it would be wise to secure our resources discreetly. If only limited food is evident at any one time, having it all taken won't mean the loss of everything available. An age-old method for doing this is by creating caches. A cache or a cache, depends on how you care to pronounce it, what part of the country you're from. A cache is a secure place of storage that can be exotic or simple. I read of a creative prepper who installed a large plastic septic tank and added shelving inside to store food and supplies. It was watertight, and who would think of looking in a septic tank for food? A more simple approach would be to vacuum seal items and place them in 5-gallon pails or larger ice chests. These can be buried in locations you record on a map. The map is much easier to hide in your house than the supplies. Caches can store food and supplies. It might be wise to mix the contents so that any given cache will provide complete needs without having to dig up too much at any one time. Another use for caching is to create forward supply points. Traveling on foot places limits of how much you can carry. Caching places consumable supplies along a known route to afford the hiker a resupply point and thus extend his range. The same can be done with fuel. It may not be safe or reasonable to carry enough fuel to reach your retreat destination, but having stabilized fuel to draw from along the way can make possible an otherwise impractical trip. Caching is also a good way to store supplies at a retreat location that is normally unoccupied. Even if someone finds the retreat and breaks in, they won't have the supplies to stay there for long. Choose locations for your caches wisely. You don't want to depend on a cache and find that someone else beat you to it. Another problem would be to hide it so well that you can't find it either. Cache locations also need to be located away from sites that are likely to be developed. It would be sad to learn that your cache is now located under a paved parking area. Good cache locations might be a secluded area between opposing lanes of a highway. These areas are often covered with trees and brush and can be over 100 feet between the inside lanes. Fresh food. Eggs can be had fresh by raising a few chickens. You don't have to become a chicken farmer to keep a family well supplied with eggs. 2 or 3 chickens can produce a dozen eggs per week, but they need a protected environment that is safe from predators. Please note that chickens don't produce eggs until they are 6 months old, and they will take a vacation once a year to molt. Feed is reasonable when supplemented with stored whole grain that can be ground in a home grain mill. Chickens will find most of their food from the yard if they can free range and scratch for bugs. They need protection from predators, such as roaming dogs, that will try to pick up an easy lunch and eat tomorrow's breakfast before it's laid. Chickens also provide good barter material. Half a dozen eggs, farm fresh eggs, or fresh eggs, will fetch high value when times are bad. Chicken manure is a rich source of fertilizer for the garden after it's well composted. Vegetables require large amounts of fertilizer to produce abundant fruit. Be sure to have a way of collecting and storing this valuable byproduct from the chickens. Fresh produce from the garden is always welcome. Start gardening now because it takes time to work the soil and prepare a garden that produces well. When purchasing seed, shop for open pollinated OP seed over hybrid seed. OP seed will produce fruit with seed that replicates itself. Seed collected from an OP variety of tomato will produce the same variety of tomato again. Hybrid seed is cross-pollinated carefully to produce a specific result, usually a more commercially acceptable fruit with tougher skin so it won't bruise easily during shipment. When seed is collected from hybrid fruit, the resulting yield may be a poor producing version of the parent plant or nothing at all. Many hybrid plants produce sterile seed. Since we are preparing for a worst case scenario, Walmart may not be open for quite a while, and some means of reproducing a garden without the spring seed sale is needed. By the way, Walmart sells open pollinated seed next to their hybrid seed. OP seed does not need to be ordered from suppliers who triple the cost and then add excessive shipping and handling fees. Start learning how to grow plants from seed. I've had poor results from tasks I thought would be simple. Don't think you are prepared because you have a can of seed in your closet. Learn how to turn those seeds into something you can eat. Storing seed follows the rule of 100, where percent humidity plus temperature equal less than 100. If your storage container maintains less than 50% relative humidity and less than 50 degrees temperature, your seed will remain viable for many years. A freezer is a good place to store seed. Select a site for your garden that can easily be watered by hand and easily watched over. Gardens are a target for nighttime shoppers of all varieties. The garden needs to focus on high-calorie foods such as potatoes, corn, carrots, peas, and beans. Preferred foods will concentrate caloric intake and last through the next harvest. Those who win this game will have become gardeners, hunters, and fishermen. Many plants mutually benefit each other, and three in particular are called the sisters. Corn, pole beans, and pumpkin each share and benefit from one another. The corn provides a place for the beans to climb while providing shade for the pumpkins, and the beans provide nitrogen for the high consumption needs of the corn. Other plants provide pest control and can make gardening much easier. Preserving garden produce is a popular use for the canner, but a more practical and economical process for preserving vegetables is a food dryer. Dehydrated or dried produce takes far less space and does not use up as many canning jars and lids. Home dehydrators can be purchased or made with plans available on the internet. They are simple and effective. A friend of ours keeps her dehydrated vegetables in jars in her kitchen. She can make a great vegetable beef stew in under an hour with a few handfuls of vegetables and a quart jar of canned stew meat. It tastes as if it was made from fresh ingredients and simmered all day. Buying everything in quantities. Buying everything in one big shopping trip is probably not within your budget now or anytime soon. Start by working toward gathering a 3-month supply of mostly canned and ready-to-eat foods that require only warming or the addition of hot water. Next, expand that to a 6-month supply to include dry foods and foods that require more conventional cooking. After that, push toward a 1-year supply of food and necessities. Ultimately, a 3-year supply is best. Finally, add as much as you can to help neighbors and friends who may not see trouble coming. It's a long process, but don't let the distance to the target get you down. Every step brings you closer. Populations of many third world countries live on a staple of beans and rice. It provides a complete source of protein and calories to sustain life. Variety may be missing, but beans and rice will keep you alive. After securing a 3-month supply of canned food, I often recommend accumulating a 3-year supply of beans and rice. It does 3 things. First, beans and rice are inexpensive and easily stored. This will get a family quickly to a survival level of preparedness. Second, knowing that beans and rice are all you have to eat will provide motivation to store more variety. And third, during adverse times, there will always be hungry souls who failed to prepare. They can eat beans and rice. Here's a link for the LDS food storage calculator and their recommendations for food quality needs. It's a handy tool for establishing your food pantry baseline. Now, this is, again, copyright 2013. I would assume that this link is still active and viable, but if not, the LDS Church, Latter-day Saints, the Mormons, have a very high interest in food preservation and preparation for difficult times. And they are the ones who offer this website with these food calculators, and it's very good information, and they offer it free to anyone who wants to. And it's http://lds.about.com/BL/FAQ, like frequently asked questions, /BLC or BLcalculator.htm. Let me hold this up and let you see the link. You can freeze the screen, and there you go. I think that gets it. Okay, that ought to be long enough. That's a lot to write down. If you freeze the screen, you can copy that down. Quantities are from data collected by those who have done research and compiled needs based on a changing dynamic. The quantities recommended may seem high to a current lifestyle of 1,500 calories per day, but in the new dynamic of physical labor, your caloric need will likely increase to 3,000 calories a day. Today, we buy our bread. When the system shuts down, we'll need to grind flour and bake bread. That will require additional quantities of wheat. That requires some experience by those who already have the skills to know those quantities that we will need. It would be wise to become familiar with the art of bread making and the associated task of living on the rough. It will also be necessary to learn how to generate and maintain yeast for baking. Grandma did it, and we can learn how. A 100-pound of popping corn isn't too much for a normal family. It can be ground to make cornmeal or popped to make sweet or salty treats. When food quantities are managed, a bowl of popcorn will be very welcome. A 1-year supply of wheat berries, whole wheat kernels before they're made into flour, are called wheat berries, is listed as 150 pounds per adult. 50 pounds is recorded for white rice. Brown rice has more nutrition but doesn't keep as well. You can juggle your quantities between varieties of grains and personal tastes, but try to keep a total of 300 pounds of grain per adult per year. Salt should be stored in much larger quantities than dietary requirement because it will find use in meat preservation, baiting game, and other creative uses. Unless you have access to clean ocean water for the production of salt, it would be wise to store very large quantities of salt. Salt was one of the most prized commodities by our pioneer ancestors and was used as pay in ancient times. That's where we get the line, someone's not worth their salt. Currently, our family of 3 consumes a gallon of milk per week. That equates to 52 gallons per year, or about 10 cans of whey-based milk substitute. Total cost for a 1-year supply of milk works out to about $40 per person. I would certainly store extra canned powdered milk, as that would become an attractive barter item during difficult times. It's cheap now, but will grow in value quickly after stores run out. During my college days, I worked as a grocery clerk in Pennsylvania. Prior to a winter storm, the milk, bread, and toilet paper were first to vanish from the shelves. Here in Texas, you can add bottled water to the list. I think of toilet paper as the new white gold. Vinegar is recommended to be stored at 2 gallons per person annually for cooking, cleaning, and canning. Most regular food requirements can be determined by a current shopping list. How many cans of vegetables are purchased for the family on a weekly shopping trip? Multiply weekly needs by 52 after compensating for fresh vegetable purchase. If groceries are bought every 2 weeks, multiply the quantities by 26. It's not necessary to buy all supplies in one shopping trip. It's surprising how fast food accumulates by purchasing 10 to 20 units of extra food each shopping trip and moving shopping trips a little closer together. Shopping in this manner allows for accumulation of provisions without drawing attention to your project. Remember, when a crisis comes, food and water may be the new currency. Public knowledge of your personal food supply could attract the wrong kind of attention. When food is purchased for storage, think in terms of meals. When buying a canned ham, visualize how many meals that will make. For a family of 3, a small canned ham will provide meat for 1 meal. That ham and its associated side dishes will be 1/3 of a day's supply. Thinking in meals will help you make sense of a list made by someone else. Don't forget drinks, such as tea and canned fruit juices. Bread and water may sustain life, but variety makes it better. Stock spices too. I have observed that onion and garlic salt doesn't cake like onion and garlic powder do. Flavor means a lot, and enjoyable meals will help during difficult times. Once you have your stockpile, begin rotating your supplies. Eat the oldest first, and when replacements are purchased, put those to the back. Keep cooking to a minimum for the first 3 months. Use ready-to-eat foods that only need warming. Better still are meals that fit the description of JAW food, J-A-W. J-A-W stands for just add water. Steaks on an outdoor grill will draw company from far downwind. Much of the potential company that could be drawn to a home during these times would not be welcome under any circumstance. Some would not think twice about making an armed visit after dark. Keep a low profile for the first 3 months. Animals. Long before the Purina Company, there were dogs, cats, and guinea pigs. Few died of starvation, and most were fed scraps from the table, caught mice in the barn, or ate grass and clover from the yard. Laying up a year's store of dog and cat food can take a lot of space and cost a lot of money. Plan on fixing a bit more for dinner and feeding the dog after the kids are full. In remote areas of Alaska and other places, dog owners make their own feed from corn or oatmeal mixed with ground fish or other meat sources. Certain foods like onions and chocolate are not good for dogs. Dogs can provide warning of intruders and protection for livestock, but a well-fed, yappy dog also reveals resources. If keeping a dog is planned, train it to keep quiet unless there is a real problem. Our little dog would need a muzzle to keep quiet. Livestock needs should be stored as well. Milk goats need good nutrition to produce well, and though chickens seem to eat anything, they lay better with good feed. Develop a regular practice of collecting and storing manure from livestock. Horses, cows, goats, rabbits, and chickens all produce beneficial manure for the garden after it is well composted. Avoid fertilizing with manure from dogs and cats, humans, or other omnivorous creatures, as it can carry pathogens. I might add that rabbit and goat manure is ready for the garden right away and doesn't even need to be composted. It is not hot like chicken manure is extremely high nitrogen and will it'll burn out a garden if you put it on there because it's so much nitrogen the plants can't take it. Then with horses and cows, they especially horses, they are not ruminants, and so there's a lot of weed seed in there. So composting that stuff is real important as well. What I'm about to say may appear harsh, but conditions could become extreme. If faced with a decision between a family pet and a human family member's life, few would choose the pet. On the other hand, many are going to expend limited food and water resources trying to feed their pets and learn that in the end it costs them a human life. Failure to accurately assess your situation can be a deadly mistake. Non-food items. Other valuable items are paper towels, paper plates, disposable eating utensils, paper cups, waterless hand cleaner, hand sanitizer, water purification chemicals, toilet paper. Great. Now, I put that all in caps back in 2013. Toilet paper, great parter material. Shampoo, toiletries, feminine products, latex or nitrile gloves, rubbing alcohol, and hydrogen peroxide. Most of these are in extreme shortage right now. Just about anything used from the bathroom cabinet could be stocked. Kitchen items should be stocked, such as dishwashing detergent, aluminum foil, plastic storage bags, manual can openers, an old-fashioned campfire coffee pot, and large pots and pans. In a situation where several families join together to provide security and mutual assistance, larger groups of people will need to be fed. Plan for triple quantities of almost everything. As diets will necessarily change, keep large quantities of antidiarrheal, antacid, and anti-gas, laxative, and stool softener. Adjusting to a new diet can be quite uncomfortable, and the two great non-pathogenic killers are diarrhea and impaction. These aren't just uncomfortable, they are deadly. And that brings us to what about water? As we begin the section on water, we've covered food. Now we're going to look at water. I'm going to go ahead and read a little ways into this, and we will finish it out probably tomorrow. What about water? If the water pressure suddenly went to zero, do you have a means of getting water and making it safe to drink? We need about 3 gallons of water per day for each person. A 6-month supply of water for one person would weigh about 4,500 pounds. Storing that much bottled water would not be practical, so a means of water treatment that assures removal of biotoxin and pathogens is a must. You should have a backpacking style pump water filter in each bug out bag and some form of bulk water treatment system at your home and retreat location. The Big Berkey gravity water filter would be a good start, but you can make a highly effective slow sand water filter for under $50. Construction details are in the back of this book. If there is no water other than from a principal water system, a plan to get to a safe place with a natural water source is appropriate. Municipal water systems depend on electric power to maintain delivery pressure. If you are fortunate enough to have good water from a well on your property, is there a means of getting that water to the surface after the power grid fails? Most well pumps require 220 volts, and that requires a large generator that both consumes fuel and makes noise. That noise can be heard for a mile when everything else is quiet, and is a call to those who might be seeking victims with resources. Hand pumps are not effective for deep wells unless they are specially designed for that purpose. They cost hundreds of dollars. An alternative is called a bullet bucket or torpedo bucket. They can be made or purchased. Price ranges from $40 to $90, but basically they are a tube with a flap valve at the bottom and a rope to pull it up from the well. The flap valve allows the bucket to fill from the bottom, and when full, the weight of the water closes the valve. I've designed a torpedo bucket that draws about a gallon of water and is easy to clean and maintain. It costs less than those I find for sale on the internet. My teenage daughter can easily work it. The design for making the torpedo bucket is in the end of the book. To use a torpedo bucket, the well cap and well pump need to be pulled out of the well. Typically, this involves loosening the bolts of the cap. Don't remove the bolts, just loosen them. The cap has a neoprene seal between the cap and the lower plate. The bolts sandwich this seal between the plates, and when they are tightened, the seal expands to the well casing and provides an airtight closure. Once the cap is removed, by the way, if you remove the bolts altogether, then the plate on the bottom of the seal will fall down into your well. You don't want to do that. You don't want to lose the parts. You just want to loosen them up. Once the cap is removed, disconnect the electrical line to the pump and the water line between the well and the house. It is assumed that the power has failed, but turn off the breaker just in case power returns momentarily or from a neighbor's generator backfeeding the lines. After the well is disconnected, some help is needed. 2 men can normally pull a well pump if they're in reasonable shape. A younger third helper is handy for guiding the flexible water line, power cable, and rope that runs from the well pump to the surface. My well is 85 feet deep, and I pulled it by myself to change the pump once. I won't attempt that again if I don't have to. By the way, I might correct that. My well is actually 165 feet deep. I only thought it was 85 feet deep. And when I actually measured it the third time, when I had to pull it again, and I had a friend with me, I realized just how long that is. Once you start pulling that well pump, you can't let go or it all falls back down in the hole. So once you start pulling, you have to keep pulling until it gets to the top. Doing that all in one effort, let's put it this way, I was sore for a couple of days. After the pump is pulled, there should be no obstructions in the way. Lowering the torpedo bucket into the water allows it to fill through the holes at the bottom. Lifting the filled bucket seals those holes by the weight of the water against the flap seal. 5 gallons of water can be drawn in just a few minutes. Water drawn from a trusted good well should be purified after breaking the well's seal and pulling the pump. Contaminants have access to the water as soon as the seal is broken. Keep the opening to the well clean and covered when not in use. An airlift pump. Another method that doesn't require pulling the well pump is called an airlift pump. It uses rising air to draw and push water up and out of the well, much like a percolator in an old coffee pot. What is needed to build this pump is enough 1-inch PVC pipe to reach at least 30 to 60 feet below the water surface in the well. Attach a 1/4 inch 100 psi rated hose to the outside of the PVC pipe. At the bottom end of the 1-inch PVC pipe, double the 1/4 inch hose back and into the end of the pipe. Secure the hose so that it won't come out of the open end of the pipe, but do not block the pipe so that water can't get past the hose. Lower the pipe with the hose into the well and fix it so that the end of the pipe cannot go further than 60 feet below the water level. Plumbers often use an oversized bicycle pump to pressure test lines to 100 psi. Since 45 psi is enough pressure to force air down 60 feet below the water surface, a pump like this works when air is released into the open end of the 1-inch pipe 60 feet below the water level. The rising air will create an expanding air dam that will lift water above it and draw water behind it. Multiple bursts of rising air lifts a large volume of water to the top of the 1-inch pipe, which can be directed into a cistern, bucket, or barrel. Since air is introduced into the pipe 3 times atmospheric pressure, it will expand as it rises and accelerates water to the surface. Some find showers no longer necessary for the one collecting water. Shielding might be advised to limit splashing of shotgun water. If you've ever seen a well being cleaned out, this is how it's done. They force air down a hose into the well cavity at the bottom, and then they direct the end of the hose. It turns around and points up into the pipe that's the riser pipe. And as those air bubbles rise, they expand, and they push the water ahead of it and suck the water below it, and water comes gushing out of the end. It creates such a volume of water rising out of the well that it forms a really big suction at the bottom of that pipe, and that's what sucks out all the sediment and any debris that's down there in the well. And I've seen some pretty good sized rocks come up out of the well, so it's got a good amount of suction value using an airlift pump. Water sources. Some sources of water are better than others. Water can contain bacteria, volatile organic contaminants called VOCs, or parasites such as Giardia and Cytosporidium. Big word. A bad parasite. Bacteria are easily removed, but VOCs and parasitic pathogens require more effort. Choosing the best water source can remove the likelihood of encountering these more difficult waterborne pathogens, but it is necessary to have a plan for dealing with less than perfect conditions. Spring water. Probably the best water source would be a natural mountain spring. Spring water generally travels great distances through earth to find an opening to resurface. Spring water rarely needs filtration or purification and is rich in healthy minerals. Well water, a second good source for water, would be established water wells. After lifting water to the surface, the water should be treated with an effective antibacterial process. Chlorine, iodine, and ultraviolet methods are approved for drinking water. The reason for treating well water in primitive conditions is that the well seal is usually compromised or removed altogether, and bacteria can contaminate an open well. Boiling the water is an effective purification means, but requires large amounts of fuel, making this an impractical solution. Collected rainwater. Missionaries have for decades used their collected rainwater over that delivered from antiquated water systems. On the Pacific island of Saipan, the municipal water system used water pipes that were constructed from bamboo by the Japanese during the occupation in World War II. The water quality from those pipes would be at the least questionable. Collected rainwater can be filtered and assumed safe in areas that have infrequent rain activity. In areas that have infrequent rain activity, it is wise to allow initial rainwater to run off and clear debris that would normally collect on a roof. Streams, lakes, and ponds. It is fourth on the list, but may be the only available source of water. These are the playground for Giardia and Cryptosporidium, as well as collection areas for volatile organic contaminants, VOCs. Water from this source requires the most treatment to be considered safe to drink. Suspended solids must be removed. Bacteria must be addressed, and parasites must be eliminated. If a chemical or petroleum odor is present in any water source, reject the source and find another. Water purification. With the absence of a sealed water system, consider any source of water as potentially contaminated. Contaminated water is a frequent cause of death throughout the world. Fortunately, purifying water is not difficult. Chlorine cannot purify water that has been fouled by contaminants such as petroleum or other chemical agents. If you smell petroleum or chemical odor from a water source, move to a different source. The problem in water that you find in ponds or streams are bacteria, parasites, and VOCs. Flocking agents. Bacteria thrive on suspended solids and are not easily killed by the addition of chlorine. Removing the suspended solids is the first step in water treatment. Flocking agents cause the suspended particles to stick to each other and become larger in mass so they can settle out. Flocking agents are used in municipal water treatment, and the necessary chemicals are readily available at swimming pool supply stores. Hydrated potassium aluminum sulfate, or alum, the same used in canning pickles, can be purchased in the grocery store for dollars per ounce or from the pool supply at 5 pounds for about $15. Since water requirements are about 3 gallons per person per day, the ability to easily purify large quantities of water is necessary. It is as easy and takes no more time to purify 1 gallon of water as it does a 55-gallon barrel of water. Now, I might add the condition of 3 gallons per person per day is 3 times more than what FEMA and other agencies tell you is required for short-term needs. And that is because your cooking and drinking needs will be about 1 gallon a day. But there is a need for more things than cooking and cooking and drinking. You also have to brush your teeth. You also have to wash your body and eventually wash your clothes. And in order to do that, very carefully monitoring the water use that you have, 3 gallons a day will just get you through. It's not excessive. Now, FEMA and the rest, when they're talking about weathering a storm or something like that, they're talking about a couple days. They're assuming that you have plenty of clothes to last you not doing the laundry for several days, so you don't need water for that. And you're probably not going to be washing your hair, and you might be taking a sponge bath, but not using a lot of water for that either. But if you're going to go the long haul, you're going to need more water than that 1 gallon a day. It's just needed. We're talking about a long-term loss of infrastructure, not just making it through 3 or 4 days of a storm. To a 5-gallon bucket of water, dissolve 2 or 3 tablespoons of powdered alum. This will make a liquid flocking agent. To a 55-gallon barrel of collected water, stir in about a pint of the flocking agent solution. Cover the barrel and let it stand for 24 hours. The solids will collect and fall to the bottom. If there are clusters of what look like snowflakes in the water, add another half pint of the flocking solution and let the water stand another 8 hours. Even green or brown water will turn clear after the flocking agent has done its work. Don't worry about drinking alum since it settles to the bottom with the solids. Carefully skim off the clear water, avoiding the solids at the bottom of the barrel. This water is ready for chlorination and will require very little. I have read that clarification of water removes over 90% of all pathogens. 2 good sources of chlorine are available for preparedness use. Both are available at the pool supply store for about $5 a pound. They are commonly referred to as pool shock, but contain high concentrations of chlorine in a stable powdered form. The problem with liquid bleach is that it loses its concentration very quickly as the chlorine gas escapes through the plastic. This is why your nose can tell you when you're in the chlorine bleach aisle of the grocery store. A new bottle of supermarket bleach will lose 50% of its strength in about 6 months. Calcium hypochlorite, 65 to 70% available chlorine, is most common. It becomes sodium hypochlorite, same as the active ingredient in laundry bleach, after it mixes with water. Standard laundry bleach is 5% sodium hypochlorite. To make a 5% chlorine solution to be able to use the drop method for disinfecting water, add and dissolve 1/2 teaspoon of 65 to 70% calcium hypochlorite to 3/4 cup of water. 1 teaspoon calcium hypochlorite will make 6 cups of laundry bleach. The drop method of purifying water with laundry bleach is to add 8 drops of 5% liquid bleach to each gallon of water to be purified. Stir the water, cover the container, and wait 30 minutes. Remove the cover and smell for the presence of chlorine. If the smell of bleach is present, the water is considered pure. Uncover the water and boil or agitate to allow the remaining chlorine to dissipate. If the smell of bleach is not present, dose the water again with another 8 drops per gallon and repeat the process as before. If after the second dosing there is still no smell of bleach from the uncovered container, dispose of that water and find another source. Chlorine is exhausted as it removes pathogens. The presence of residual chlorine is a sign that no further pathogens are present. If no residual chlorine remains after dosing 16 drops of bleach per gallon of water, it must be assumed that significant pathogens are present in the water and that it is unsafe to drink. Sodium dichloryl triazine, big word. Sodium dichlor is another available pool shock that is also very stable and will store for 10 years or more in powder form and has an advantage that it is pH neutral. However, pH will not be changed much at the rate of 1/2 teaspoon per 55 gallons of water. Chlorine is a reactive substance that should be stored away from all metal objects. Store either calcium hypochlorite or sodium dichlor in an airtight plastic container and separate from metal objects. This means outside or in another building and away from any metal objects you wish to keep, including electronics, tools, and AC units. Parasites such as Giardia and Cryptosporidium are not removed by chlorination. I'm probably butchering that name. It's a great big word. They are effectively removed by micropore ceramic filters, but these are impractical for large volume needs. 2 methods have been found effective for removal of these pests. Boiling kills the parasites and expels residual chlorine, but it requires time and fuel. A more passive method has been very effective and nearly eliminates the need for chlorination as well. It is the slow sand filter and can be constructed easily. Slow sand filtration is a term for using sand to establish a biomass purification system. Simply put, there are 2 kinds of bacteria. Good bacteria feed on bad bacteria, and both are removed in a sand filter. In a sand filter, the top few inches become a breeding ground for good bacteria. This bacteria mat is called a hypogel layer or Schmutzdeck. Below this, the fine sand filter filters out suspended solids, and below the sand is a layer of gravel to keep the sand from plugging up the drain. The drain comes back up from the bottom and drains about 2 inches or more above the sand layer. This is an easy filter to build if you start with a plastic 55-gallon barrel or large plastic garbage can, new of course. Begin with a hose or perforated PVC pipe that allows water in at the bottom and passes through the side of the barrel or can about 28 inches from the bottom. With the drain in place, add 6 inches of pea gravel, small rocks, or other material that will prevent sand from plugging the drain. Over this material, add 20 inches of fine sand. Fill the filter with water to cover the sand with a few inches of water. This will take some time to saturate all the media. Once it is filled and saturated, let it stand for a week to 10 days for the friendly microbes to grow in the top layer of sand. Pour a few gallons of water through the filter each day to keep the water from going stagnant. All that is left is to mount a 5-gallon pail with holes drilled in the bottom, like a big shower head, to cover the top of the filter. The pail is to prevent the added water from stirring up and disturbing the hypogel layer. As you add water to the filter, clean water will be pushed out the exit pipe. This filter has been shown to remove Giardia, and again, that Cryptosporidium, as well as bacteria and virus. More directions appear in the chapters at the back of this book. Volatile organic compounds, or contaminants, VOCs. Charcoal filtering and boiling are the two most effective means of removing these from water. At any time, if you smell chemical or petroleum odor in water sources, it's good to seek a different source. Reverse osmosis systems in many homes today are good at purifying clear water, but require pressure to operate and are very inefficient when it comes to the amount of water filtered versus the amount of filtered water delivered. Most of the filtered water is dumped down the drain as bypass water. The bypass water can be collected and used for plant watering, laundry, or toilet flushing. When there is an abundant supply of water, an RO might provide a water purifying answer after a few requirements are met. First, RO units require water pressure of 10 to 12 psi to work. In a manual world, to develop that kind of water pressure from a water tower, the tank would need to be 23 feet above the RO unit. Lifting 5 gallons of water 23 feet every day would quickly get old. A better option would be a 12-volt on-demand RV water pump that can be purchased through RV Supply. Water would still need to be drawn to a ground level tank, and electric power would need to power the pump. The internet has a lot of valuable information, and I reference several good sites in this book, but keep in mind that the internet will be down when the information is needed most. It would be wise to print critical information and store it in notebooks. If the resources are available now, laminate the pages in acid-free laminating sheets to protect them. Tomorrow, Lord willing, I'll begin the section on finding water and then moving on into the topic of fuel. Hope this finds you well. Hope you're enjoying the read. Thanks a lot for being part.